get 100 on it?
No, because I made a couple of stupid mistakes. But
You have already submitted it?
well, you can take it twice, so I just wanted to see if I totally messed anything up.
Okay.
So anyway, so we can go through starting with number 3. The in an ANOVA hypothesis test, we reject the, is that the null hypothesis? Yeah.
Yeah, I don't know about this.
When there is sufficient evidence to indicate at least one mean is different from the others. That's true. Everybody got true?
I have a true either.
Okay. And then what requirements need to be checked? I had the second two. They had to be normally distributed and the variances are equal.
Yep.
Yeah. Data is, oh yeah. This is what I have to.
Okay. Okay, so to check if each group is normally distributed, do the following, which would be the
QQ plot.
Yeah, that's what I have.
The Q.
Yep. We assume the variance in each group is the same if the following happens.
The second one.
Because this is what I read in the textbook.
Yeah.
Yeah, the second. That's what I put too.
I'll read the next ones so you don't have to keep doing them all. So 7. An ANOVA hypothesis test is equivalent to conducting independent two-sample t-tests between every pair of samples. If there are 3 samples, there are 3 pairs. How many pairs are there when there are 4 samples?
I found 6 as answer, but I did it manually. I don't know if there's a way to do it in Excel.
I don't know either. I did it manually also and got a 6. So.
Yeah, me too.
Okay. Excuse me.
I'll just keep going. So, okay. Do you guys have your Excel stuff out?
Yeah.
So the data in this was collected to determine how the design of a soccer shoe affects the accuracy of a kick. There are 5 types of shoes, and also just wearing socks for a total of 6 groups. Each row represents a kick from 10 meters away from a target that was hung 115 centimeters up from the ground. The column accuracy is the distance in centimeters from where the ball impacted the target to the center of the target. So smaller numbers are more accurate. What is the minimum or smallest variance for the 6 groups? I had 27.208.
That is also what I got.
And
27?
20, what did you get, Maxie?
So you got it in variable 3?
Oh.
In word 8.
So yeah, so you look at the variances, right, for the soccer?
Yeah.
Under variance, and you find which one is the smallest, and it's that answer.
Yeah.
And the highest would be 53 something?
Yeah.
Yeah.
Okay. Yeah.
So the minimum was 27.208, and the maximum is 53.158. True or false, the test for equal variances is satisfied for these data. True.
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 Construct a QQ plot for each of the 6 samples. Each of the samples are approximately normal based on what you see in the QQ plots. True or false?
Oh, sorry. True.
I put true.
Okay.
I also put true. So if you perform one of those tests, you will observe that the p-value is 0.081. Remove the SOX data and perform the test again. I don't know why I said text. Spelling error. Anyway, what is the p-value when we remove the SOX data?
0.309.
That's what I had.
Wait.
We're on 12. What did you get on number 12?
Is it in the Excel?
Yeah, you just delete the last set of data.
Variable 6 you delete.
Yeah, from the SOX or whatever.
The p-value 0.006.
0.309.
No. What I see here, the p-value is 0.007. Is that
So when you go into it, did you delete everything from variable 6? So in where you have your 6 variables, go delete all the numbers under variable 6.
okay?
And then look at your p-value after you delete those numbers.
Okay. I have to delete all the 5 first ones.
Just the variable 6.
Oh, okay.
So just the last column.
Okay, I have 0.089.
No.
That's the normal one.
No.
Here, let me screen share.
Yeah, I don't think I get it.
Okay, so this is this test for soccer, right? So you need to go to variable 6 and delete all the numbers in that column.
Yeah.
And then that should give you this p-value over here of 0.309.
Yeah, this is what I did. Unless okay. Let me go back to the Excel sheet that I have. For the soccer shoes, my first variable was A.
Yes.
My second was B.
Yep.
My third was C. D was the fourth. E was the fifth. And socks was the sixth one.
Yeah.
Yeah, so it should be okay.
And you deleted this column and it still isn't right?
Yeah, it still isn't right.
So maybe you copy and pasted, had an error there somewhere when you were moving the information over.
Maybe it's true. Let me find out. Okay, I'm going to start over inputting the information. Okay. Yeah. Sorry, guys. I am putting you on hold.
It's okay.
Yeah, no worries.
We've probably all done that to each other at some point during these meetings.
Yeah.
Sorry, I keep coughing.
No, it's fine.
I have another economics test next week.
If I have the same value as you in the descriptive statistics, this means the information I inserted, they must be the good ones. I'm just guessing. What do you think?
So you have the right p-value now?
No, I am almost there. I am inputting the socks now.
So just leave socks out because we're getting rid of that now. So only do the first 5 variables. Don't do socks, just do A, B, C, D, and E.
Yeah. My p-value still doesn't add up. What is your DF?
4. Between groups is 4. Within groups is 95.
Yeah. And where do you find this again? The 4?
Under DF, under right there. Can you see my screen? Did the screen share work?
It worked for me. I can see your screen.
Yeah, but this is something you put by yourself.
No, it does it for you. All you have to do is put the information into this left side into each variable. It does the rest of the calculations in these tables by itself.
Okay, I did something wrong in my stuff. I have the p-value correct now. It is 3.309.
Yes.
Yeah.
Yeah.
Yep, that's right.
I'm going to download a empty Excel thing so that I don't get mistaken in it anymore.
I'm going to stop my screen share if that's okay.
Yeah.
Okay, so 12 again is 0.309. 13, the test statistic for a test, here's F statistic, is the p-value area to the right or left of the F statistic?
Right.
Yep.
Why do you say it's right?
Because that's what is said in the reading.
Yeah, I was gonna say the book told us.
There's like a picture in the book where, yeah, I don't know. It was just like a right skewed kind of chart. So that's, I don't know.
Yeah, but
Sometimes I don't know why.
the p-value, the F statistic, it is always right skewed. But
Yeah.
was it the same thing for the p-value? Because it has to be to the left of the F statistic.
P-value doesn't follow the same, no.
Because as we can see here,
Hold on, I have my reading.
yeah, I don't get it.
So, okay. So,
It's the problem is with the explanation. It's not obvious. Maybe Angela, can you explain what you understand, Becca? I don't know.
This, it was just in the reading. So there was a chart.
here, I'll share my screen.
I was just gonna share my screen, but you can share your screen, that's fine.
Yeah, I got it. So, that's this part, right? The F statistic. I guess that's distribution, but it's still F. But yeah, it is. So, trying to figure out a better way to explain it.
It's just a characteristic of the F distribution. Like other distributions we've seen are on like that bell curve. And this distribution is to the right.
It's a right skew instead of the bell shape.
Right. So it's just like saying that's just one of the characteristics of the F distribution. I don't think it really like has bearing on how we do the problems.
Maybe
Yeah.
I am thinking in a weird way, because the let me go back to the test. The p-value, the F is 1.216 and the p-value is 0.309. So to me, it's I never see a lower value to the right of a higher value. You see what I'm saying?
Well, I see what you mean. So you're like looking at the results of on the Excel sheet.
Mm-hmm.
And this has nothing to do with like the answers we're getting. Okay. It's just saying that F statistics are right skewed. That's just how they are.
Okay.
And that's like, that was just saying in the reading, like there was a list of 3 things or something. It's right skewed, negative, I don't know, that kind of stuff.
I have it pulled up, yeah. It gives you all the characteristics, so
yeah, it's just like, it doesn't have to do with our answers. It's just like, that's what it looks like, kind of a thing.
Yeah.
Okay.
But I see what you were saying, though. I just don't think that deep into it, so.
Yeah, thank you.
Okay, I'll read 14. If everyone's good with that one, right?
Yeah, I'm okay with it.
Okay, so researchers at Consumer Report analyzed 3 types of hot dogs, namely beef, poultry, and meat. Blah, blah, blah. For each of the 54 hot dogs analyzed, they recorded the type, the calories, and the sodium level. So 14 examine the calories first, construct Q plots for the calories, and compare the variances to determine. So determine if the assumptions to use that have been met. So were they met? I put yes, the first one, that they were met.
me as well.
Where are we in the 14?
Yeah.
Okay. So you took the first one, the assumption have been met.
They have, yeah, the first one that they have been met.
Okay. Okay. Now, can I read this one?
Yep.
Run an ANOVA test to determine if the mean number of calories is the same for all three types of hot dogs. You should find the degree of freedom are 2 and 51, that F 16.074 and the P 0.30 with a level of significance equal to 0.05. What conclusion do you draw?
I had the last one that says we have sufficient evidence to claim that at least one of the hot dog types has a different mean number of calories than another type.
And that's what I had too.
And we know that because in the previous question, we said that all of the requirements were met. And so that confirms that we have the sufficient evidence to prove that claim.
Okay.
If that makes sense.
I think without you, I would have chosen the third one. Yeah. I have to study more. I feel more at ease this week, but not as you do, guys.
So 16, I'll read it.
Okay.
Now let's examine the sodium levels. Construct QQ plots of the sodium level for each of the three types of hot dogs. You should see that the QQ plot for poultry suggests a possible problem with the normality assumption. The smallest variance is 7180.75, and that number is the largest. Have the assumptions, wow, I'm really struggling right now. Have the assumptions been met to use the ANOVA test?
Yes.
No.
Me, I took the second one.
Wait, they have not been met?
Nope.
Yes, they have. Number 16?
Mm-hmm. It's the
Why
third one down. The
Well-
assumptions have not been met.
Did you turn in the quiz?
Yep.
So did I. And I have the assumptions have been met and it gave me a point.
I say they had not been, and I got a point.
Well, that's weird.
They
Yeah.
couldn't be met, right? Because there was a problem with one of the QQ plots, which means it's not normally distributed. So that's one of the things that wasn't met to do the test.
Oh, I did the Q plots and I thought they looked fine. But that's weird though, because I have the assumptions have not, or the assumptions have been met. It's okay to assume each group comes from a normally distributed population. And we can also assume that the variances are equal. And I got 1 out of 1 on that. So I guess I don't know what the right answer is then. Because were any of the QQ plots like way crazy?
Well, also, isn't it that your smallest variance has to be like 4 times bigger than, or 4 times, yeah, hold on.
Less than 4 times. Which it isn't. Or like it is, I mean. Because 7,180 times 4 is 28,000 something. And the largest here is 10,000. So I guess, I don't know. You can just put whatever you want, Maxie, and then tell us if you got it right. Because we both got it right, but we also maybe because one of the Q plots wasn't like perfect, they allowed both answers.
Yeah, maybe.
Because I was like, well, because in some of the reading stuff or whatever, or I don't remember where I looked, a lot of the Q plots didn't look quite, but they were like, these are close enough, so it's fine. And
So
so
probably is that.
yeah, it's fine. So
I'll read our last two. Are we good to go on to 17 anyway? Are you okay with that? Okay. So, despite the possible problem with the QQ plot for poultry, you decide to use ANOVA to determine if the mean sodium levels are the same for all three groups. What is the p-value for this test? And I had 0.179.
that's also what I had.
Is that what you had, Maxie?
Mhm.
All right, so 18. What conclusion can you draw about the mean sodium levels of the three types of hot dogs? Use a level of significance of 0.05. And I did the second one.
Yeah,
We do not have sufficient evidence to reject the claim that all three hot dog types have the same mean sodium levels.
This is what I have to.
Yeah.
So the only doubt I have here is regarding 14, not 14. Regarding 16. But anyway, it's time for me to go to bed. I will submit it. Yeah.
Sorry it's so late.
Yeah, it's okay.
We'll go back to normal time on Thursday, right? So,
Yeah.
thank you, guys.
You're welcome, guys. Have a good night.
All right. See ya.
Bye.
Oh.